Good morning, everyone, and welcome to the sixth OEM Espresso webinar dedicated to web integration. My name is Giacomo Brioschi, and I'm a senior solution architect working for the OEM EMEA pre-sales team. I'm testing right now my Espresso, and in the meanwhile, I want to tell you a bit more regarding embedded analytics. As data-driven decision processes are becoming more and more important for organizations, having the possibility to have business intelligence embedded as a unique entry point in the core application users work with on a regular basis becomes a competitive advantage to empower employees, customers, suppliers, and partners with the information they need right where they work to answer a question, make better decisions, and take action faster. Let's go to see it in details. Before starting, let's have a look to the agenda for today. We will start with a brief introduction of what do we mean with web integration that will lead us to evaluate together the different integration strategies we offer to embed Qlik inside your solution, followed by some integration examples I'll provide you during the webinar. But our SaaS platform offers more than just embedding the dashboard, since a series of augmented analytics features have been developed within Qlik Cloud that empowers the user decision-making skills. I'm talking about natural language insights, AutoML, alerting. Hence, we will see some example of how it's possible to embed them thanks to our API-first approach. At the end, we will have a dedicated slot to answer all the questions I strongly invite you to raise during the webinar. Before starting with a bit of introduction to web integration, I just want to show you a web application responsive template running via a local HTTPS web server that will act as a parent web application where we will embed Qlik contents during the webinar with the different integration method we offer. Together with this template, I spin up a Qlik Sense SaaS tenant where I have imported an application containing sales data that you can see here on the screen with 3 different sheets and a custom theme. In addition, I built to transform the look and feel of the app with the same color palette of my web application where the visualization will be embedded. Within the tenant management console, we have also pre-created respectively a content security policy that is a methodology implemented in modern web browsers to disallow web page from accessing resources outside its own origin without explicit permission. When you embed the content using iframes like visualization sheets or entire analytic experience into your web application, adding a content security policy reference is necessary to allow the content to render in the application. As a last step, we have created as well a web integration that is a feature for handling course requests in Qlik Cloud. By default, no course communication is allowed to your tenant unless a web integration has been configured to allow it. In our example, we are creating a web application and we want to embed or fetch content from our tenant. Then a web integration with the list of allow whitelisted origin, where I have put my local web server, needs to be created in the management console. We are back now to the presentation, and before going on describing the different embedded strategies, I want to make sure that it's clear what we mean with embedded analytics. Qlik wants to ensure that what is created within the data analytics SaaS platform remains not only available within it, but rather that it can be integrated within external platform where corporate decision-making processes take place. So if we create a Qlik Sense application containing dashboards, the visualization and the dashboard themselves, which are obviously accessible on the Sense tenant, can be integrated into portals, business systems, and services that you develop for your end customer. This is because our integration methodologies are based on standard web technologies. Hence, we don't have a proprietary language that binds us to Qlik technology, but rather the system is completely open to integration since it's based on HTML, CSS, and JavaScript. The way to embed Qlik in a third-party system is to create a mashup. that is a web application that reuses content from one or more QlikSense application to create a single result within a single graphical interface so that the Qlik analytics are fully integrated seamlessly within the native application that hosts them. Thanks to the flexibility of our technology, we offer different methods and level of integration, each with a different complexity. Which one is right for your needs depends on the design requirements you have. In any case, as you will be able to explore in the following section, everything can be done by calling the Qlik native APIs included within the standard product in SaaS. The simplest and the most known method of embedding into your solution analytics built in QlikSense SaaS is certainly through the use of an iframe. An iframe is generally used to show the content of a web resource, in our case QlikSense, within a frame of a web application or main portal. When to use it? When you want a quick solution. In fact, I call it one-click integration. When the look and feel of QlikSense satisfy your needs. But keep in mind, however, there are themes where you can change the look and feel of QlikSense and you can apply them to the embedded app. Last but not least, if you want to embed all the app's self-service part, that is where a professional user can create new personal sheets, this is the way to go. We offer two different types of APIs for iframe integration. Let's start from the first one, that is called Single Integration API. These APIs allow you to embed via iframe a single sheet or a single object of a sheet within a QlikSense application. In order to use it, we need to open the Qlik app. From the app menu, we can select a single sheet, and by right-clicking on a single object or by clicking on the top left menu, we can find in the contextual menu the option to embed respectively a single object or the full sheet as I'm doing. Between the embedding option, we can, for example, allow or disable the interaction, show or not the selection bar, apply a default bookmark, or select a custom theme in order to render the app with the look and feel of our web page. Qlik is modifying the embedding URL according to the parameter we select. When we are done, we can open a preview of the iframe, and then we can copy the generated URL. By going back to our app, we can see that we have already created in iframe.html file an iframe tag, but the URL is empty. Hence, we go to the JS file that drives the HTML page and we copy and paste the generated URL inside the code to change the default iframe URL. By refreshing the page, we can see that the Qlik sheet is loaded inside the web application, and the user can interact with the engine as it would be inside the QlikSense tenant, but with an integrated experience. The second set of APIs we offer to embed Qlik using an iframe are called App Integration APIs. These are the APIs that allows to embed the entire app, including the app menu, where you can switch the sheet and add a new one. In order to show you how self-service for professional users can work, we have published the app in a managed space, where a professional end user has access. As we did before, we open the app and we navigate to a sheet. From here, we copy the URL on top and we update the iframe URL of the iframe tag situated at this time in the self-service.html file. This is the page of the web application where we are going to embed the self-service. By reloading the page, we can see now the app has been embedded. As a difference from single integration APIs, in fact, we have the upper contextual menu available, where the user can see the different sheet and create new one as its own personal sheet. Here we can use, for example, the editor to create new visualizations by dragging and drop the visualization type and the associated measure and dimension. Or we can use as well in Site Advisor Augmented Analytics feature to ask some question like, sales trend for last year, and to retrieve answers enriched with insights that we can add to the new sheet. Hence, this demonstrated that by using iframe together with app integration APIs, we can embed the full self-serving experience we offer by default in the product. It's now time to explore the second embedding strategy we offer. In addition to a simple iframe embedding, in fact, Qlik provides developer with a complete set of JavaScript APIs to connect to the Qlik engine, retrieve a previously generated app, retrieve its object like chart, filter, and so on, and render them within a web-based solution. We can say that the integration experience that you have using the JavaScript libraries is a 360 degrees integration, which allow a bidirectional communication between the information and object contained in your web application within the information and visualization object contained in the Qlik Sense app. You can use it when you typically have an existing portal or web page and you want to embed Qlik inside of it. To obtain the results described above, for the web integration project, we offer different methods and libraries. But today, we will focus on Enigma.js combined together with nebula.js, our new framework agnostic library to embed Qlik visualization objects. Enigma.js is an open source library that helps you to communicate with the Qlik associative engine. You can use it as a wrapper to connect to a Qlik associative engine and to use Qlik's API methods. The Enigma.js library can be used as an SDK to retrieve an application, the object of an application, and the hypercube that will be rendered using nebula.js. On the other hand, nebula.js is an open source library developed on GitHub and is a collection of product and framework agnostic JavaScript libraries and APIs that helps developers to integrate visualization and mashups on top of the Qlik associative engine. Let's see how this works in practice. What we are going to do right now is to embed Qlik objects inside the div tags of the following HTML page. The first thing we have to do is to load the current JavaScript libraries, Enigma.js, Nebula, plus each single visualization type we are going to use in our web application. This can be done through the installation of an npm package or through a script import, as we are doing here. In the HTML file, we have placed some empty div, each one with its own div ID. These are the containers where we are going to embed Qlik object. In the JavaScript file that is performing the integration, we need to firstly retrieve a CSRF token in order to open a WebSocket connection to Qlik engine. Any web solution interacting with the platform needs to provide a valid CSRF token as a measure against cross-site request forgery, including WebSocket connections. Once we retrieve the token, we can then create a connection to the Qlik engine using Enigma.js library that allow us to open the app in order later on to retrieve the single visualization objects. In Qlik, each single application has its own unique app ID. You can retrieve directly from the URL when you open the app from the tenant. As a last step before rendering the objects, we need to create a new embedding instance from Stardust, that is the Nebula primary component which contains the APIs for integrating visualization. Hence, we are declaring what's the app to be embedded and what are the visualization type we are going to use. Here we are to the key step of the div tag integration. Rendering an existing object of the app is done using the render method on the instance returned by the embed function, which at minimum requires both the HTML div, where you want to render the Qlik visualization, plus the object ID you want to render. How to retrieve the Qlik object ID? It's enough to open the sheet where the object is located, right-click on the object, and select Embed. Here the object ID is displayed, and we can easily copy and paste it into the code. By refreshing the HTML page, we are now able to see how we have completed the integration of a first object that is a KPI representing the total number of orders. By using the same approach, we perform the integration of the other objects in the other div tag of the page. The final result is a seamlessly integrated experience where it's possible to exploit the power of the associative engine through an embedding scenario, navigating through the different visualization objects, apply selections, and having one single entry point for data-driven decisions. Additionally, by inserting a single line of code both in the HTML page by adding a new div and in the JavaScript file by performing the selection bar integration, it's possible to display the selection context as in the native Qlik Sense experience to allow users to keep track about the context of navigation where they are and to see which filters have been applied so far to the data. To end up the part dedicated to this integration method, I want to demonstrate to you why I call the JavaScript integration a 360-degree integration experience. I want therefore to show you how I can trigger an action to the Qlik engine, for example by resetting the selections, from a native component of my web page, in this example the rubber icon in the top right part of the page. This can be done by inserting an handler in the JavaScript file that is making use of the clear selections method of Qlik Engine API. Please note that there are many operations that you can perform with this set of APIs. Hence, this is just a drop in the ocean regarding what could be done with them. We are back to our presentation to see an enhanced version of the div tag integration called on the fly. Instead of pre-creating the objects in the Qlik Sense app and recall them from the JavaScript code, it's possible to create them directly on the fly in the JavaScript of the web page using nebula.js. Through this set of methods, we offer you the ability to generate charts or other Qlik objects on the fly, which uses the data model dimension and measure that we have built in the app. The code to render them reuses the same render method used for div tag, with the difference that instead of having the ID of the visualization object, here we are going to specify which type of visualization we want to render and what are the dimensions and measures. By refreshing again the HTML page, the on-the-fly bar chart representing the sales for each category of product is rendered and can be used like it's an existing Qlik object. When do I suggest to use it? When you want to offer to users the possibility to choose between different possible representation for the information they want to analyze. Like this more advanced example you can see on my screen, where I can change measure, dimension, and visualization type for an on-demand analysis. The last embedding strategy that remains to be mentioned, but which we will not cover into details today due to the lack of time, but also because it's the least frequent approach, is the one called data only. Thanks to the APIs, you can also extract the hypercubes that are extractions of the data loaded in the apps. You can then obtain back the dynamically calculated data according to the filter from the associative engine and reuse them to build your own front end with your own graphical libraries. We will see a quick example of it in the final demo. As you may have understood, the strategies presented have an increasing rate of complexity from one to the other. This is the true potential of Qlik Embedded Analytics, which is to offer a possible method for each level of experience and use case to be implemented. We have almost came to the end of our webinar, but before leaving the right time for your final question and curiosities, I would love to highlight, as you might have already noticed, how over the years the data analytics part of Qlik has evolved by adding, thanks to a cognitive engine, additional augmented analytics features within the platform, which was also recently enriched thanks to AutoML. a built-in auto machine learning platform within Qlik Cloud Analytics Services for generating automated machine learning models and delivering them as a predictive endpoint. To meet your needs, the augmented analytics feature exposes APIs to be integrated within your solution, where the embedded analytics of Qlik charts are enhanced and enriched with features that allow the user to obtain additional insights from the data. Let's see them in action in the final demo related to a manufacturing use case. In this demo, we have a web application for quality and maintenance related to the production of 6 milling machines. From the overview page, you can see that we have embedded some Qlik charts using the main embedded strategies presented before, together with the data-only approach for the KPIs in the upper part that are made by HTML component, but underneath retrieve the data from the Qlik engine. The dashboard is interactive, as you can see from the filter I can apply, and is possible to maintain the selections context by displaying the selection bar. At the navbar on top, there is a panel where we have created an alert center, where via APIs we retrieve all the alerts the user created regarding the data. And by clicking on one of them, like the percentage of scrub by machine, we can go to see the details directly on the tenant. Moreover, we have created a custom chatbot where, thanks to the natural language APIs, it's possible to ask to Qlik Cognitive Engine some questions like the one I'm asking, related to the scrub by scrub measures. From the API call, we retrieve as an answer not only the result as a Pareto of the main scrub reason, but even some additional insights that can tell to my quality engineer that the length of the material measured by sensor 2 is the main reason of scrub for about the 45% of the total scrub generated. In the predictive maintenance sheet, instead, we have embedded a sheet with a representation of the shop floor, thanks to a custom map where we have added layer with the status of each machine and the measurement of each sensor that we can view in details thanks to the mini chart. On the top right part of the sheet, then, we have integrated AutoML for machine failure prediction. Thanks to the machine learning experiment created on the tenant in Qlik Cloud, the maintenance engineer can see that there are machines that have higher probability to fail soon, based on the result of the algorithm. By selecting one of the machine, in this case the machine number 6, it's possible to use a what-if analysis in real time to make a simulation of tuning the process parameters to reducing the failure probability. To conclude the demo, I show you how to use in the embedded context the Create an Analysis feature available in Insight Advisor in order to create guided advanced analysis on demand, like an anomaly detection analysis of the measurement of sensor 2 along time. We came to the end of the webinar.